Indicators are chemicals that change color in the presence of an acid or a base. They typically have two or more different colors that they change, depending if something is an acid, neutral, or a base, or even what pH range they have within, say, the acid part of the pH scale. This indicator we're going to look at right in this video is about cabbage, red cabbage specifically, and it's called anthocyanin. Now, normally we would do a coloring activity where we would color the different shades that universal indicator changes on its scale from acidic up to neutral and into the basic region. Remember, something that's 7 is neutral, and anything below that is acidic, and anything above that is a base. And then we would do the same activity with the cabbage indicator that we have extracted. There's a video attached to this set of materials that you can watch and see how that goes. You can even do it on your own. You just would have to buy some indicator or some red cabbage in the grocery store, chop it up, boil it. I'd recommend using distilled water. Tap water might change it because there are some chemicals and salts in there. The chemical that is in red cabbage, and in fact all natural products that have red, blue, purple, or any of those types of shades, it's called anthocyanin. Now, anthocyanin is a general chemical and has lots of different specific types of formula within this anthocyanin family. Here's the basic structure. Here's another structure of it. You can see the ring here and then the fused ring there. These represent alternating double bonds. Next year when we talk in Chem 1111, if you take that, we're going to refer to those as delocalized pi bonds and see that they're called aromatic ring structures. By changing these side groups, these side chains, by either adding hydrogens or hydroxides or other chemical substituents, we can make fine changes in the chemical. And then we can get different shades of blues or purples or blacks or plum, depending upon all of the different little minor changes that can happen within this basic structure. Here are some examples of those, and then the specific names they're called. Here are some more pictures. Now, all of these colors, and there's quite a variety of them, come about because of differences in anthocyanins in their chemical structure. Light hits them, interacts with those alternating double bonds and those aromatic rings, and then emits it in a wavelength that allows us to see in these colors. Again, here's what you're probably going to see for the red cabbage. Here's what the universal indicator is, and I want you to notice that they do not have the same color scheme, particularly from neutral on up through the basics. Okay? These links are just to Wikipedia links, and I simply typed in this as a search or that as a search, and you'll find that information. Hopefully you found this interesting. We're going to use some other indicators in our titrations, specifically phenolphthalein. Feel free to look that up if you wish.